Welcome back to part 2 of our review of lesson 20, tangents in a circle. We're at question number 4 now, and circle O is inscribed, meaning it's written inside of the triangle RST. And what happens is the sides of the triangle are going to be tangent to the circle itself. Okay, so basically the idea of it being inscribed means that the circle touches all three sides of the triangle. So tangent points are at M, N, and P, and RP is 7. So let's mark that off. RP is 7. And RT is 17. So RT is 17. Well, that would mean in this case that TP had to be 17 minus 7, or 10. And we're also told SM is 5. Then which of the following is the length of side ST? Okay, well, here's the thing. The next concept that comes to tangent segments is going to be if two tangent segments of the same circle meet at a point outside the circle, then the segments must be congruent. So we're given AP and BP in this diagram here. AP and BP are tangent segments meeting at point P. Okay, and so what happens here? Well, okay, so let's kind of write down some of the things that are occurring. So first off, line segment PO is drawn. And our reason would be a segment can be constructed. A segment can be constructed. Between 2 points. Okay, so that's our first thing. So, and I'll put a little hat on top of the line segment PO, so it's line segment PO is drawn. Okay, all right, so we got that. That's kind of drawing a diagram. The next thing we know is that, in this case, that the angle A, and angle B are right angles. And again, the reason for this would be in this case, well, before this actually, before we say this, we have to make the statement. Sorry, I'm jumping the gun here. We have to make the statement that PA is perpendicular to PO. Okay, so PA is perpendicular to PO. All right, and not only that, we're also going to say in this case, PB is perpendicular to oh, and not PO, sorry, AO. Oh, shucks. All right, PB is perpendicular to AO. All right, and so what's the reason for this? Well, our reason will be that a tangent segment is perpendicular to the radius it intersects at the point of tangency. Okay, remember I got that from last time. Okay, so now we can say in this case, now we can say angle A and angle B are right angles. And our reason would be perpendicular lines you see how badly I typed, ladies and gentlemen, so sorry about that. Perpendicular lines form right angles. All right, okay. And now he's saying, well, this kind of sounds like a proof, and you know what? It is. So I'm kind of doing the proof now. All right, so let's do an entire page. So here we go. All right, so we know in this case that OA is congruent to OB. And we know this to be true because in this case, all radii are congruent. We know in this case that OP is congruent to OP. Our reason, a segment is congruent to itself. That's the same as flexible property, ladies and gentlemen. And now, one last thing. We know in this case that triangle, I'm going to pull that triangle symbol up here. So triangle, because I'm running out of space. Triangle OAB, and triangle, not OAB, sorry, OAP. Again, I'm rushing through this. Triangle OAP and triangle OBP are right triangles. And our reason, if a triangle has a right angle, then it is a right triangle. Okay, so what's it leading to? Well, here's the thing. What leads to now is that we can say that triangle OAP and triangle OAB, so I'm just going to copy this because it's just easier to do that. Instead, I'm going to put the congruent symbol between. So are congruent. Okay, and our reason would be hypotenuse leg. Hypotenuse leg. Hypotenuse leg theorem. Okay, which says in this case, if the hypotenuse and leg of one right triangle are congruent to the corresponding hypotenuse and leg of another right triangle, then the two triangles must be congruent. Okay, so why is this the case? Why is this important, ladies and gentlemen? Let me just do this. Okay, well, to prove the triangle is congruent is kind of important. And the reason for this is that if I prove the triangles are congruent, then I can make the statement that, okay, right angle, sides are congruent, flexible property, the triangles are congruent. Then that will leave for us to say that PA and PB must be congruent. Okay, so we add here that PA and PB are congruent. Okay, and our reason, corresponding parts. Of congruent triangles are congruent. Okay, and that's why, ladies and gentlemen, this is the reason why, and this is a kind of proof form, that why the two tangent segments of the same circle meet at a point outside the circle, here the segments must be congruent. Okay, so with all that written out, let's go back to our problem here. That being the case, let me make this full page. So that being the case, that would mean that RP and RM are going to be congruent as well. So RM must be 7. SM and SN must be congruent. Therefore, SN must also be 5. And finally, TP and TN are congruent. Therefore, TN must be 10. So the question is, what is the length of side ST? The length of side ST has to be 10 plus 5, which is 15. And that's choice 2. Okay? I know it's a roundabout, long way to try to explain things, but you know, I want to make sure you guys understand where things come from. Not just, here's a rule. Okay? But now that we have this, We know that all that 10 segments that are drawn from a point outside a circle will form congruent segments. All right, let's apply this again to the next problem here. Okay, for question number 5. All right, so in our right diagram, the 10 segments are drawn from point A. Well, maybe we're not going to use it for this one here. Here we're told in this case, in circle K, tangents are drawn from point A to B and C on the circle, and the measure arc BC is 96 degrees. Well, okay. What is the measure of angle A? All right. Well, here's the thing. We have a quadrilateral. Quad BACK, quad back. And we know that since AB is a tangent segment to the circle and KB is going to be our radius to it, that's a right angle. Same thing with angle ACK, that's a right angle. Well, the next thing we remember, going back to what we know about are central angles. A central angle, remember whose vertex is on the center of the circle, is going to intercept an arc, which is arc BC. So this arc BC has the same angle measure as the central angle. Therefore, this must be 96. Now we're left with angle A, this angle here. Well, we know in this case the quadrilateral is 360 degrees. So 360 minus 90 minus 90 minus 96. Okay. And so break out the calculator, just to make sure. So we'll do 360 minus 90 minus 90 minus 96. And we're going to get 84 degrees. So the measure of angle A is equal to 84 degrees. Again, we use the idea of a quadrilateral having 306 degrees, and in this case, from here we know that angle ABK and measure angle ACK are both right angles or 90 degrees as well. We can find the measure of central angle of angle BKC be the same measure of the arc intercepted, which is 96, and then we just subtract those values from 360, leaving us a leftover measure of 84 degrees. Okay, ladies and gentlemen, hope this was helpful to you guys. This is the end of part 2. Again, if you found this video helpful, please please make sure you like the video, as well as leave any questions or comments below. Really appreciate you guys watching. And again, hopefully that whole point where I went over where or why the 10 segments are congruent, hopefully we'll be able to explain to you where things come from, not just the formula, but why things work out the way they do. In any case, ladies and gentlemen, thank you so much again for watching, and I ask that you please take care and be safe.